So as we've started to talk about, and I'm sure you've seen in your videos where you're starting to talk about heat. So, what is heat? We're going to look at our definition, and then we will go through some examples to get a better idea of what we should think about when we think about heat. So, our definition: the transfer or flow of thermal energy from one substance to another. Now, we're also going to be talking about thermal energy when we talk through our examples. So, something that I like to think about when I think about heat that kind of puts a good picture in my head is thinking about different beverages and how they respond after they've been sitting out or if you add something to them. So, in thinking about a hot cup of coffee, all right, now you can fix coffee a lot of different ways. One of my favorite ways to fix it is a pour over. So with a pour over, you'll take boiling hot water. So I'm sure you've seen boiling water before, but take a minute to think about it. Boiling water, all right, first for a little while, you set your pot on the stove with the water in it, and the water is very still. But you put it on the stove to get it hot, right? What starts to happen as the water gets hotter and hotter? Well, as it gets hotter and hotter or has more heat or more thermal energy, the water starts boiling. It's moving quicker. So when we're thinking about heat, the more heat something has, the more it is moving, right? Think about the boiling water. As you added more heat, the water started boiling, right? Because it was moving more quickly. So it has more quick moving energy, right? And so thinking about a hot cup of coffee, if you sit it out and you leave it out all day, right? You leave it out all day. Is it going to be the same temperature when you come back if you just left it in a regular cup? No. It is going to be a lot cooler, more than likely lukewarm, right? A cool temperature. Maybe not cold, but it won't be hot like it was when it was good to drink. So, another thing about our heat is heat always flows from warmer to cooler objects until it reaches equilibrium, or it reaches the same temperature. So thinking about our cup of coffee, all right, the heat within the cup of coffee is flowing to the cooler object, the air around it, all right? So you can even tell that when you put your hand over something that is very hot, you can feel the steam rising from it. Even though you can't always see it, you can feel it when you put your hand over it. Or if you've had really hot food that just came out of the oven or just came out of the microwave, you can feel that around it. And that is the heat flowing from the warmer to the cooler object. Now, the object doesn't always have to be something you can see. Remember, we've been talking about air, right? Even though you can't see it, it's all around us, right? And sometimes the air can have more heat or less heat, depending on the other factors surrounding it. So the other example that I thought of, again, another beverage, was a glass of water. So if you have a glass of water that's lukewarm, you want it, or not too cool, you might want to put ice in it to cool it off because cold water is always just so refreshing. So let's say you leave it out for a while. You probably notice something after it sits out for a good bit. You notice that your glass starts to sweat around it, and the ice cubes probably aren't as full as when you first put them in. This is because the ice cubes have less heat, right? They're colder than the water that surrounds it. So again, remembering what in our notes here, and from what we know about heat so far, heat always flows from warmer to cooler object. So the warmer object in this scenario is the water surrounding the ice cubes. So this heat is transferring from the warmer water to the cooler object until they become the same temperature. Now, if you left this glass of water out for a few hours, you would notice at the end of the few hours, your ice cubes have completely melted and you're only left with the water. And so it reached equilibrium. The ice cubes became the same temperature as the water. So they melted and became liquid with the water, with the liquid water. Okay? So those are two examples that help me. You can think about food, you can think about these liquid beverages. When you think about what happens to them after a long time of being out in the open, right? Think about what happens, and that helps us to understand heat. Now remember, our objects with more heat, they are quicker, they are fast moving, right? And we can learn about why that is so later on.